Okay, so now I have more than one vector, but in my example here is I've got two vectors. So I'm going to be finding y, the orthogonal projection of y onto these two vectors. So I can't possibly do it justice in a picture, but let's just say I've got these two vectors, right? I'm in R3, so I've got these two vectors down here, and y is up here. So I'm going to be taking the orthogonal projection onto these two vectors of u1 and u2. And by doing the dot product, I'll find that projection y hat that's down here, right? That would be, this y hat would be in the span of u1 and u2. So very rough drawing of what I'm trying to do. So y hat, to find y hat, it's the same thing, just more than once, right? So I take the y, so that would be -1, 4, 3, dotted with my u1, 1, 1, 0. And then I'm going to divide it by u1 dot u1, 1, 1, 0, 1, 1, 0, and then 1, 1, 0, plus. Then I'm going to take y, -1, 4, 3, and dot it with my u2. And that's going to be all over my u2 dotted with itself. -1, 1, 0. Okay, so let's go do the fun multiplication here. So -1 plus 4 and 1 plus 1 plus, and to do this, I'll get 1 plus 4 and 1 plus 1. So it's a -1, 1, and 0. Okay, so this gives me a 3 halves, and this gives me a 5 halves. And so let's add these together. So I'm going to go slow here. 3 halves, 0, plus -5 halves, 5 halves, 0. So adding these together, I get a -1, a -1, and a 0. So that's my y hat. And that's all this is asking me to find. So to find the orthogonal projection, that's the y hat, onto the span of y1 and y2. So I found this vector down here that's in the span of the u1 and u2. Sorry, I said that wrong, u1 and u2. Okay, so this one's going to be a little longer because now I have 3 vectors, right? 3 vectors to write y as a linear combination of. So you might want to try to turn off the video to see if you can do this yourself, right? So this vector y, 4, 3, 3, -1, I'm going to write as a linear combination of these 3 vectors. So that means I take this and dot it with u1 over u1 dotted with itself times the vector u1 plus. Then I'm going to take y. Oops, that's supposed to be, I can't erase on this thing now. 1, 1, 0, no, times dotted with u2, -1, 3, 1, -2, u2 dotted with itself, -1, 3, 1, -2, times the vector u2, plus. Then y dotted with u3, -1, 0, 1, 1, -1, 0, 1, 1, times, okay, here we go. So I get 4 plus 3 minus 1 all over 3 times this vector here. That's a 1. Plus. So dotting these guys together, I get -4 plus 9 plus 3 plus 2 all over 1 plus 9 plus 1 plus 4 multiplied times this vector plus. Then I get -4 plus 3 plus 1 all over 3, right? All times this vector, -1, 0, 1, 1. Okay. So this gives me 6 over 3 plus, this gives me 10 over 15 plus, and this gives me a -2/3. So this gives me 2 times this vector, right? So 2, 2, 0, 2 plus, and this is going to give me a 2/3 times this vector, right? So I'm just going to leave it outside for a second. And this gives me a negative 2/3 times this vector. Okay, so I could take steps to do this, but I'm going to run out of room here, so I'm just going to do it quickly. I get 2, 4, 0, 0. So this is my y hat. What did I have that there? That's not that. That's not true. This is my y hat. My y hat is this vector. Okay, so they wanted me to write y as the sum as the one orthogonal to it, right? The vector in the span of it and the one orthogonal to it. So first, that means this is my first step. First step is find y hat. Second step is to find z. So how do you find z? That's y minus y hat. So take my original vector y, subtract off y hat. That gives me 2, -1, 3, -1. So that's my z. So final answer is y can be written as y hat plus z. So my y hat, that's as far as it will go. So my y hat is 2, 4, 0, 0 plus 2, -1, 3, -1. Let's see if it works. 4, 3, 3, -1. That's y. Yes.